AWS EMR service and architecture. As the title suggests, let's look at the AWS EMR service in detail. So what are the objectives of this section? We'll look at what is AWS EMR, then we'll look at its features, the various usage patterns, and then we'll look at some case studies. Then we'll look at how EMR integrates with other AWS services. Then we'll look at the EMR AWS architecture. This is where we're going to be spending most of our time. We'll look at all the various architectural features. Then we'll look at launching an EMR cluster. What does it take to launch an EMR cluster? So what is AWS EMR? AWS EMR is first of all a regional service, and it really provides Hadoop as a service. You can download Hadoop and install in your own VMs, or you can just simply take Hadoop as a platform service. And that's what EMR provides you. By the way, this is the AWS EMR icon. So the AWS EMR service makes it easy for you to quickly and cost effectively launch a Hadoop cluster to process big data in the cloud. It's a very important service to help you with big data challenges. Of course, at the core of AWS EMR is the HDFS storage, the Yarn platform, and the MapReduce engine. And there are, of course, many other application platforms that are built on top of the Hadoop service, such as Hive, Pig, Spark, Mahout, and so on and so forth. Don't forget, HDFS is used for distributed storage, Yarn is used to bring in various processing engines, and MapReduce is used to break the process into map and reduce phases that run across multiple machines. Okay, so what are the features of AWS EMR? First of all, it's easy to use. You can easily create a cluster. If you have to create a cluster from scratch by downloading the Hadoop software, installing it, it's a lot of work. Here, web-based UI, which is the admin console, you can point and click and create a cluster, create a Hadoop cluster. You can also use an API or a command line tool to create a cluster, which will be up and running within minutes. So it's an easy to use interface to launch a cluster. It's also low cost. You don't have to have any upfront hardware investment, and you only pay for the resources you actually use. The idea here is that you launch a cluster, you use it, and then once you're done, you basically destroy the cluster rather than running the cluster all the time. Once the processing is done, just simply terminate the cluster and stop paying. And so you might say, wait a minute, what do I do with all the data that is in my cluster? Well, you can store all the data in Amazon S3, where you actually pay less for the storage. And you can also use spot instances. If you recall from the EC2, in EC2 you can have spot instances, and you can bid for these spot instances, and you can use these spot instances to launch your cluster so that you pay even less when you're using machines for computation. It's resizable in elastic clusters. Let's say that you launch a cluster with one master and 4 slave nodes, and you want to increase the capacity of the cluster. You can change it to 6, 8, 10, 20, whatever the number of machines you want. Nodes. You can just add nodes, and within a few minutes you'll have those nodes available for you to do the processing. In the same way, you can also shrink a cluster to reduce cost because you don't really need that much capacity anymore. You can use Amazon S3 or HDFS. One of the cool things about AWS EMR is that it actually integrates with S3. So you can actually have all the data in S3, and then you can have your MapReduce program run in the cluster, which will pull the data from S3, process the data, and write data back into S3. Now, if you have multiple steps, let's say you have to execute a job step 1 and then job step 2 and then a job step 3, you can have the intermediate outputs of job step 1 and job step 2 in the cluster, but have the entire result, the final result, to be in S3. So the original data source will be in S3, the final results will be in S3, and the intermediate files can use HDFS. The point I'm trying to make is the AWS EMR actually has integrated S3 and HDFS, so you can use both of them. You can also create parallel clusters. In many organizations, they will launch 20, 30 machines to create a cluster, and that is the only cluster you have. It's always running. Whereas here in AWS EMR, the working model is you have your data in S3, and then you can launch a cluster which will process this data. Now, if somebody else wants to process the same data and they want to do it in their own cluster, they can do that. So you can actually launch 2, 3, 4 different clusters, and you can be processing the same data in using different algorithms, or you can be processing different data sets. The point is you can launch parallel clusters in the AWS EMR system. There is a wide range of Hadoop ecosystem application support. When you talk about Hadoop, it's not just HDFS, Yarn, and MapReduce. There are other applications that are built on top of Hadoop that you know, Hive, Pig, HBase, and several other of those services or applications that can be brought in and used with AWS EMR. And it's all done with point and click. All you have to say is just bring this tool in or bring this application in, and it'll bring it in for you. It's pretty straightforward. They do support a whole bunch of Hadoop ecosystem applications. There is also integration with business intelligence tools. There are several very popular BI tools in the marketplace like Tableau, MicroStrategy, and Datameer. And there are drivers available for you to integrate with such tools in AWS EMR. There are also several management tools. You can manage the clusters using an EMR console, which is the web interface that typically people use. You can also use a command line interface to launch a cluster, destroy a cluster. You can also use a web service API or a variety of SDKs. This is very similar to all the other services that you have in AWS EMR. In terms of security, you can run EMR in Amazon VPC, which is the virtual private cloud, in which you can configure networking and security rules. EMR also supports IAM users, groups, and role policies, so you can implement those functionalities also as part of the cluster. Now, security does become important when it comes to AWS EMR because you're actually bringing in your data into the cloud. So you should have these capabilities, and they have that as features of AWS EMR. There is also support for MapR. If you recall, MapR is actually a distribution from another company, mapr.com. They have their own proprietary implementation of Hadoop, especially the file system is a native file system that they have created. If you want to run MapR, you're welcome to run MapR inside AWS EMR. It is part of the platform. That's an option that you have. One of the great things about the MapR platform is that it allows you to NFS mount your distributed file system. Some folks like that, and if you want that feature, then you can use MapR. In terms of instance options, when I say instance options, I mean the various virtual machine instances. EMR, Amazon has a whole series of virtual machines or virtual servers that you can use. These virtual servers have various capabilities in terms of size, such as memory, performance, and so on and so forth. So what you can do is when you launch your cluster, you can match the virtualized servers to the processing needs of the cluster. If you want a server that has big storage, then you can use one of those VMs which has a lot of storage in it. If you want a server that has a lot of memory, you can pull up a server or get a VM or a bunch of VMs for your cluster that has a lot of memory in it. So you can choose between various instance options that you have for the cluster machines. In terms of user control, when you launch a cluster using Amazon EMR, you have root access to the cluster, and so you can install whatever software you want. In many PaaS services, they allow you to launch a PaaS service, but they don't allow you to log in into the VM. In AWS EMR, they allow you to log in into the VM, and then you can configure other things. In fact, they even give you hooks so that you can install other kinds of software in your VM. So they actually give you nice control. If you recall, when you did past Elastic Beanstalk, they allowed you to log in into the Elastic Beanstalk machines, the application server machines. It's very similar. So it's good that you have access to the machines. And I'm going to show you later on how you can log in into your AWS EMR machines if you want to. In terms of usage patterns, let me kind of describe 3 usage patterns. One is clickstream analysis. Many organizations have websites, they have ads that are being displayed and they're being clicked upon. And if you want to do clickstream analysis, you can do that with AWS EMR. You can bring in all the data into AWS EMR, and then you can do your processing within Amazon. If you are interested in the medical field, which is the field of genomics, you're welcome to bring in the genomic data. That's vast amount of scientific data sets, and you can process them very quickly. So researchers use AWS EMR to bring in the data, process it, and then take the results back. There is also log processing. If you have web servers all over the world, you can bring in all the web server data so that you can do analysis on what pages people are clicking on, what web pages are popular. So you can do log processing of web access log files. You can do log processing of structured data, semi-structured data, and so on and so forth. So there are several usage patterns. The most important thing is you all know that Hadoop, you all know that big data. The most important thing is that you all know that big data is affecting every industry. And here I've shown you 3 use cases. There are also several case studies. I just wanted to mention a couple of case studies. Case study, which is Vivaki, and another one, Netflix. Vivaki is a French communications company. They needed to process large amounts of data to provide business intelligence for digital ad campaigns. And basically what they did was they migrated their system into AWS Cloud, and they used AWS EMR to process all their data. And the story is that they reduced the operating expenses by 75%. You're welcome to go ahead and read the case study right here and see for yourself as to how this company reduced their cost by moving into the cloud. There is also another case study, which is Netflix. Netflix has been a big user of AWS infrastructure, all the different kind of services that they have. And there is a case study there which talks about how Netflix moved into AWS, and they wanted to measure its user streaming experiences. And so they actually moved to the cluster. And currently, from what I understand, they operate 10 plus petabytes of data warehouse on S3. And there is a blog over here that kind of talks about how they use Hadoop platform as a service in the cloud. Now, of course, they use a lot of other services, but this one specifically talks about how Netflix uses Hadoop, especially the Hadoop AWS EMR service. The cool thing about Amazon Web Services is that when they bring in a service, they actually integrate it with several other services that's there in their ecosystem. And that is completely true for AWS EMR service also. The EMR service integrates with other storage services. S3 is very important. The basic idea there is that you bring in all the data and store it into S3, and then whenever you want to process them, you launch a cluster, load the data into the cluster, you process it, and then put the results back into S3. So there is nice integration that exists between AWS and S3. It's called EMRFS. EMRFS is the file system that they use, which is the EMR file system interface. And I'm going to show you how they do that in one of the examples. Then there is also AWS Dynamo, which is the NoSQL database that they have. You can store data in NoSQL database, and then you can read data from NoSQL database into AWS cluster, and then you can process it and put the results back in Dynamo. So there is integration that way. There's also integration with RDS, which is your relational database service. And there's also integration with Kinesis. Kinesis is for stream processing. If you've heard of the Storm project, Kinesis is the Storm equivalent of the AWS EMR. So they have that integration too. The point I'm trying to make is AWS has several storage services with which AWS EMR seamlessly integrates. There is, of course, integration with EC2, because when you're launching an AWS EMR cluster, you're actually launching VMs that are in EC2, which is the Elastic Cloud Computing. It also integrates with CloudWatch for monitoring and health. I will show you in my demo how CloudWatch is used to get statistics and displayed back to the user. Okay, so let's look at the EMR architectural components. First, we will look at the Hadoop distribution that is supported as part of AWS EMR. Then we'll look at the cluster concept in AWS EMR. Then we'll look at the nodes, the various kinds of nodes that they support. Then we'll look at the cluster lifecycle, the lifecycle through which the cluster goes through. And then we'll look at something called bootstrap actions to initialize a cluster. And then we'll look at the concept of steps, which is the series of workflow that you can do as part of cluster launching and performing tasks. And then we'll look at the various applications that are supported as part of AWS EMR. In terms of Hadoop distributions, EMR provides a choice of a couple of Hadoop distributions. You can either choose the Amazon Hadoop, which is a Hadoop distribution that is coming from Amazon itself, or you can use the MapR Hadoop, which is a distribution that's coming from MapR. You can choose one of these two. All right, so let's look at the differences between these two distributions. Now, before I do that, I wanted to point out what do I mean by choosing the distribution. The point is that when you're launching a Hadoop cluster, you can say, well, I would like to use the MapR software. That is the software that is coming from the mapr.com company, versus I would like to use the Hadoop software that is coming from Amazon itself. It's almost like when you launch the RDS service, you have the opportunity to choose between the Oracle database versus the MySQL database. In the same way, you have the option to choose between the MapR Hadoop versus the Amazon Web Services Hadoop implementation. So let's look at the Amazon Hadoop distribution. It's also called the EMR release. So when you launch a cluster, they're going to ask you which distribution you want. You basically choose the EMR distribution or the EMR release. Now, there is also the EMR AMI version. You'll see that too. When we do the demo, I'll show you that. That's deprecated. Please do not use the AMI version. Just use the EMR version, not the AMI version. This Amazon Hadoop distribution is actually packaged by Apache BigTop. Apache BigTop is an open source project which actually tries to bring in all the different Hadoop ecosystem projects together and make a distribution. And the Amazon distribution is based upon the BigTop distribution. Of course, it is an open source distribution with custom AWS related add-ons. So what really Amazon has done is that they have taken the Apache BigTop distribution and then they have added a bunch of other things. For example, EMR-FS to integrate with Amazon S3, EMR Kinesis library for stream processing, EMR DDB, which is the EMR DynamoDB to integrate with Amazon DynamoDB, and EMR S3 distcp for parallel copying of files from S3. If you have a lot of data in S3 and if you want to bring it into the cluster, they actually have a distributed copy mechanism available which uses EMR-FS as the file system interface. So they have provided a bunch of libraries and tools for you to integrate with the various AWS services. Now let's look at the MapR Hadoop distribution. The MapR Hadoop distribution is the distribution from MapR, and there are several versions of it. There is the M3, M5, M7 versions, and there might be other versions in the future. The MapR distribution is an open source Hadoop distribution with some custom proprietary add-ons. Like I said, they have their own implementation of the file system. They also have their own implementation of NFS to NFS the HDFS file system with different machines. They are high performant clusters, at least that's what they claim it to be. A high availability, data protection. They claim a bunch of features. I haven't really worked much on MapR, but it's definitely one in the marketplace. It's not the top priority for many companies because they have this proprietary software, but it's available. In this class, we are not going to be using MapR. We are going to be using the Amazon Hadoop distribution. But I do want to tell you that there are some companies that use MapR because one of the features that many companies like is the NFS access. You cannot mount the HDFS file system as an NFS file system, whereas you can do that with the mapr file system because it's written in C++. If you want that feature, then you may want to use mapr. Anyway, we're going to be using the Amazon distribution. Okay, so now let's look at the AWS EMR cluster. In Hadoop, we learned that there is a master node and there may be several slave nodes. That's where the data gets stored and processing gets done. And all of them are communicating with each other. The AWS EMR guys have taken that same concept but extended it a little bit further. What they've done is that they have a master node, but then in terms of slave nodes, they actually have two kinds of slave nodes or two types of slave nodes. They have core nodes and task nodes. So some of the slave nodes will be core nodes, some of the slave nodes will be task nodes. And I'm going to talk about the differences between them in the next few slides. But just remember right now that they have one master node, and in terms of slave nodes, there will be several core slave nodes and several task slave nodes. In terms of the kinds of EMR cluster, you can have transient cluster or you can have a long-running cluster. In other words, in transient cluster, you can have a cluster that comes up, does the work, and shuts down. In the long-running cluster, it comes up, does the work, and hangs on. You can log in, you can interactively work with it. So these are the two types of EMR cluster. Now let's go ahead and look at this in great detail. Transient clusters, let's look at that first. Transient cluster is when you run your cluster as a transient process. Bring it up, use it, shut it down. How does that work? Well, you launch the cluster using your admin console, and when you launch the cluster, you basically say where the input data is. It may be in S3, EBS, DynamoDB. You configure steps which would be processed, and there might be multiple steps that you may want to provide, say do this work, then do this work, then do this work, and all those steps will be done. And the intermediate steps may use HDFS to store the data. It may start by loading the data from S3 and then go through different jobs and then eventually store the data back in S3, and all the intermediate jobs will be using HDFS. Like I said, it finally stores the result in S3 and then it'll automatically shut down the cluster. So the idea here is that you configure the cluster with all the information that is needed to process the work, and then you launch it, machines come up, they process, and it automatically shuts down. It's a great model for a cluster that is performing periodic processing tasks. So maybe every hour on the hour, you launch a cluster which will do the work for 15-20 minutes, or maybe every 6 hours, or maybe every day, you launch a cluster that will process for 2-3 hours and shut down the cluster. And so you're actually only paying for the processing time. Shutting down the cluster ensures that you're billed for processing time only, right? Only the processing time when the cluster is up and running. So the rest of the 22 hours when the cluster is not running, you're not really paying for it. That's one of the biggest features of AWS EMR. You pay for what you need. That's one of the biggest selling points for AWS EMR. In terms of long-running cluster, once again, you can launch the cluster, you can load the input data, you can configure steps, you can process those steps. You can also interactively process the data and query the data because the cluster doesn't come to an end. It doesn't stop. It doesn't terminate. It may do all the steps, but then it waits. The cluster goes into a state called the waiting state so that you can log in and you can do whatever you want to do. You don't even have to log in. You can actually use the admin console to configure the steps. The idea here is that you can have a cluster running longer and you can interactively work with it. And then when you're done, you can explicitly shut down the cluster when you want to shut down. Explicitly do it when you want to do it. This is a great model for data science and interactive operations. And of course, you're billed as long as the cluster is up. In terms of node types, we talked about master and slave nodes. Like I said, the AWS EMR guys have actually kind of created three types of nodes, if I may say. They have the master node, which is like the traditional Hadoop master. They also have core nodes, which is like the traditional Hadoop slave nodes. And they have something called the task nodes, which are Hadoop slave nodes, but they are restricted. They're restricted in terms of they don't store any data. Again, we'll talk a little bit more in detail in just a few slides. Just remember that there are three types of nodes: master node, core nodes, and task nodes. And for each one of them, there is actually a group. For the master node, there is the master instance group. For the core nodes, there is the core instance group. And then for the task node, there is the task instance group. It's always good to configure things in terms of groups, because then you can administer them as groups. And so that's what I'm trying to show you over here. Notice there is the master instance group with the master node. There is the core instance group with the core nodes, which is the C1 and C2 core nodes. And then there is the task instance group, which has the task node 1, task node 2, task node 3, and task node 4. You will notice that the task nodes don't have any storage associated with it, whereas the core nodes have it. And then there is also the S3 integration. All these guys can talk to S3. All right, just to kind of give you a big picture. Now let's look at each one of these nodes in a little bit more detail. Okay, so let's look at the master instance group, master nodes. This is the master instance group. It contains one master node. There's only one master node, and this master node controls the cluster. If you recall from Hadoop, the master node runs the master daemons. So in this case, the master node will run the resource manager daemon, which is responsible for managing the resources in the cluster, the storage resources and the task resources and the job resources. So it's the daemon responsible for allocating resources to applications, and it acts as a scheduler. It will also run the name node daemon, which is responsible for the distributed file system. And then applications such as Hive, Pig, all those applications are installed in the master node. So if you want to do any work with Hive and Pig, you simply log in to the master node and you can interactively work with Hive and Pig. It also monitors the health of core and task nodes. It's always watching these nodes and seeing if they're doing the right thing, if they are up and running. Traditional stuff that Hadoop does. Now let's look at the core group. In terms of core group, the core instance group contains all the core nodes, and these core nodes have HDFS storage associated with them. Here's the core group. The core group has two core nodes, C1 and C2, I'm going to call them. And notice they have their own file system, their own disk. So I'm going to say disk 1 and disk 2. They are their own disks. And so the core nodes that are in the core instance group run the data node to manage the data in the file system, which is your distributed file system. They also run node manager daemon for running the various container, for running the various tasks that need to be run when a job is submitted. The nodes exist for the life of the cluster. As long as the cluster is running, these nodes that are in the core group are going to be running. They're always going to be there. So when you create a cluster, you may say, I want a cluster with two core nodes, and they will be always running, and they have the distributed storage with it. You can add more nodes or shrink them if you want to. For example, if you decide to go to 4 core nodes, you're welcome to do that. You're welcome to bring it back to 2 if you want to. But you have to have some minimum number of core nodes running in your system. Don't forget that when you shrink the core nodes, if I remove one of the core nodes out, I actually lose the disk that goes with it. So I'm actually shrinking the capacity and the I/O capacity of the HDFS file system. Now let's look at the task group and the task nodes. The task nodes are optional. You don't really have to have any task nodes. In fact, when you configure a cluster, you can say I want 2 core nodes or 10 or 20 core nodes for that matter, but no task nodes. And you can bring in task nodes whenever you want. Of course, you can bring in more core nodes whenever you want. You can bring in less core nodes or remove core nodes whenever you want. Anyway, so let's look at the task instance group. The task instance group runs only the node manager daemon. They only run node manager. So task 1, task 2, task 3, task 4, these are the VMs. They will only run the node manager daemon, only the node manager daemon. Notice they are not running the data node daemon because there are no disks associated with them. that allow you to store any data like you have in the core instance groups. And you can add task nodes whenever you want. You can add it when you launch the cluster, or you can add it later on whenever you want to add more processing capacity into your cluster. You can dynamically add task nodes also if you want to increase the processing capacity. Remember, I said to you that you can have steps. So in between steps, if you want, you can increase the capacity and then bring the capacity down. Now let's look at the Amazon S3 and the various node types. S3 is critical in Amazon. We saw that it's one of the most important service when it comes to storage, especially low-cost storage. And in this case, this is big data. With big data, you need some kind of a storage service, and there's a nice integration between S3 and AWS EMR. So the S3 works as the underlying file system, producing the capacity required in HDFS. So the idea there is that you store all your data in Amazon S3. This is a recurrent theme in Amazon. They always say, bring in all your data into S3, store it over there, and then launch the cluster whenever you want, process it, and put the data back or the results back into S3. It's a common pattern. The core and task instances read-write to S3. It's possible to do that, and they do that using what is called EMR-FS. Just like HDFS, there is something called EMR file system. And the same storage can be used for more than one cluster. The same S3 storage can be used for more than one cluster. So you can have one cluster using the S3 storage, another cluster using the same S3 storage. If you recall, S3 has automatic multi-AZ replication, cross-region replication, and also high durability. There is also fine-grained access control where you can access it over the web. For those of you who have taken AWS Cloud Computing class, you know that S3 has all these features in it. Just wanted to kind of review that. Okay, so now let's look at the cluster states. We talked about launching a cluster. So do the clusters have various states through which they go through? And the answer is yes. When you launch a cluster, it goes into a state called starting. Now, it may be in the state of starting for 4 to maybe 6 minutes because it has to launch all these different virtual machines. So when you see the cluster state as starting, that means you're seeing that it's coming up, all the VMs are coming up, and the software that is needed to run Hadoop is also being installed as part of the cluster state starting. Then there is a state called bootstrapping. If there are any bootstrap actions, if there are any pieces of software that you want to customize and install or customize the machine, you're welcome to give those scripts. We'll talk about bootstrapping later on. That would be the bootstrapping state. So when it's actually bootstrapping, which may take a few minutes, depending upon what is it that you're trying to do, or it may take a few seconds, you would go into a state called bootstrapping. Then the cluster gets into a state called running. That means the cluster is running at this point. Now, when the cluster is running, it means it's actually executing steps. It's actually doing work. You can configure the cluster with steps, and step is a Hadoop job, Hive job, Pig job, any kind of a job that is running using the cluster processing. And when it's running a job, it goes into a state called running. When it's done with the jobs or when it's done with the steps, and I'll talk about what the concept of a step is, it goes into a state called waiting. When it's in the waiting state, you have the opportunity to log into the cluster and do whatever you want using your command line console, or you can also use the admin console to add more steps if you desire to do that. Once everything is done, it may go into a state called shutting down, where the cluster is shutting down, and then completed, when job is completed. Eventually, when everything is done and the cluster is terminated, it goes into a state called terminated. If there is any problems with the cluster in terms of job failing, and if the cluster stopped because the jobs failed, then it would go into a state called failed. The most important lifecycle states are starting, which is when you know that the cluster is actually starting. This is what happens when the cluster is launched. You'll see the cluster in that state for 5 to 6 minutes. The other important state is waiting, What this means is it's waiting for you to take some action. If you want, you can terminate the cluster at this point if you don't have anything else to do, in which case it will go into the terminated state. This is the final state. Terminated state is the final state. That happens when you terminate the cluster. So in the waiting state, you interactively work with the cluster, and when you terminate it, it goes into the terminated state. And then you see the cluster running, that means it's doing some work. It's doing some step actions. Here's another view of the life cycle of the cluster. Notice when you launch the cluster, it goes into a state of starting. And then the bootstrapping takes place for all the machines. And by the way, whenever you launch a brand new machine into the cluster, it has to go through the bootstrapping state also. Then the cluster comes into a running state, and then it checks to see if there is any job flow that is configured, any steps that's configured. And if there is steps that's configured, then it goes and executes the step, and then goes back and executes a step and goes back, executes a step and goes back. And if there are no steps to execute, then it shuts down the cluster, going into a state called shutting down, which happens very briefly, and then the cluster is completed, finished. Or you go through the cluster and then you decide to terminate the cluster, in which case it goes into a shutting down state and then becomes terminated. Or maybe there is an error in your job flow, there is something that failed, because of which the cluster will shut down, but then it'll basically go into a state called failed. So that's the life cycle of a cluster. Whenever you see the cluster in a state, now you know how and why it got to a state. Now let's look at bootstrap actions. Bootstrap actions are scripts that run on nodes during node setup. Whenever a node comes up for the first time, whether it's the master node or the slave node, which could be of two types, core or task nodes, the bootstrap action scripts run. Now, bootstrap action scripts are scripts that you write that it will execute when the node comes up, before the job actually executes. This is to prepare the nodes if you want to customize the node to do certain things, to have certain piece of software installed maybe in the cluster. These scripts execute on any nodes that have been added later on. Remember I said to you this is elastic provisioning. If you want to later on add 4 more core nodes, once again the bootstrap actions will take place when those 4 core nodes come about. And it executes as Hadoop user, that's the user ID, with root privileges. So you can do whatever you want as root. There are some predefined bootstrap actions. For example, you can configure Hadoop cluster-wide settings. These are the Hadoop configuration settings. You can configure daemon settings, for example, JVM options for the daemons. And then there are things called runif, where you can say run if this condition is met. So you don't have to run the same bootstrap action in every machine. You may want to run different kind of bootstrap action on different types of machine. That's the idea. So they give you some level of control there for bootstrap actions. Okay, now let's talk about steps. EMR defines a unit of work called a step. Now, when you take a traditional Hadoop class, you hear this concept called a MapReduce job or a Hive job or a pig job. An EMR step is like a Hive job or a pig job or a Hadoop MapReduce job, to be precise. They call it a step. They call a job to be a series of steps. So there are some differences in terms of traditional Hadoop job versus what EMR calls as a job. So in EMR, they have the concept of a job, and a job contains several steps. And these steps are really Hadoop jobs. Okay, so a step is a user-defined unit of processing that typically manipulates the data. Like I said, it could be a Hive program, it could be a pig program, it could be a Spark application, it could be a streaming program, which is Hadoop streaming, or even a custom jar, which could be a Hadoop MapReduce jar or any processing that you want to do in that step. And you can configure multiple steps for a Hadoop cluster. So the cluster job can have multiple steps in them. And these steps actually are executed sequentially. There is actually a very interesting Hadoop subproject called Oozie. You can almost compare this to Oozie, except Oozie is a little bit more rigorous in terms of you can have branching logic and looping logic. You don't have any of those things here. It's just a bunch of sequential logic. Okay, in terms of configuring steps, you say what type of step it is. You give it a name. You also say where the script is located for that step, which is actually put in S3. Remember, the type of step could be a Hive, Pig, or a MapReduce job, and that's really what you're doing over here. And so if it's a Hive job, then you're putting in S3 the Hive script. If it's a Pig job, then you're putting in S3 the Pig script. So that's the script location. If it's a MapReduce job, then you're putting the Hadoop jar file in S3. And so that is the script location. The input S3 location, which is where the input data is, and that's optional. The output S3 location is the output of this job going to go into S3, and if it is, where? And then any arguments that you may want to pass for your Hive job or a Pig job or the jar job, to be precise, the Hive step or Pig step or jar step, because that's what they call in AWS EMR. And then action on failure. Well, what should you do if you execute a job or if you execute a step and that step fails? Should you cancel and wait on the cluster, or should you just terminate the cluster? That's actually an option that you can set when you configure the step. And when we go through the demo process, you will see all these things. Right, so a step itself goes through several states: pending, to running, to completed, to canceled, because the step was canceled because of an earlier step, and then failed. Okay, so let me show you a picture. Let's say that you have a job, and that job has several steps, and we know that each one of the steps is a Hadoop job, Hive, Pig, or custom jar. So let's say it finished step 1, and step 1 was to decrypt the data, step 2 was to process the data, and step 3 was to encrypt the data. And notice that step 1 is completed, step 2 is completed, it went through its states, step 3 is running at this point. Notice step 4, 5, and 6, and so on and so forth are all pending. If for some reason this job fails, it will move into the failed status, which means the rest of the jobs are not going to run and they will be moved into the canceled status. Canceled status. So that's how the step processing and step lifecycle works. In terms of applications, the EMR distribution simplifies the Hadoop ecosystem by bringing in and integrating all the various Hadoop applications on top of the Amazon Hadoop distribution. So with a click of a button, you can bring in Hive, Pig, Hue, Mahout, Spark, Presto, Oozie, whatever you want. In fact, whatever they support. And they keep on adding support for newer sub-projects. That's something that they keep up. It's very important to keep their customer base happy. Okay, so what does it take to launch a cluster? Now let's logically go through what it takes to launch the cluster, and in the next section I'm going to show you how you would actually launch a cluster through a demo. There are two different launch consoles. You can launch using the quick cluster configuration, which is a fast and easy mechanism to launch a cluster. Within a minute you can launch a cluster. This is a less flexible option because you cannot really control your debugging, because by default debugging is turned off and you cannot change it. You cannot control the termination protection, which is the EC2 termination protection for the VMs. In terms of VPC configuration, that's not available. You cannot pick and choose the Hadoop ecosystem applications. You get some default applications prepackaged. And there is less control on hardware configuration. But it's fast and easy. You can launch a cluster very fast. There is also the advanced cluster configuration, which is a little bit more complex configuration. Here, it's much more flexible. You can set the debugging. You can also tag your EC2 machines. You can do VPC configuration. You can pick and choose the Hadoop ecosystem applications. You can pick and choose the instances, instance types that you want, of mixed types if you want to. If you want your core nodes to be of one machine type, you can do that. If you want your task nodes to be a different machine type, you can do that. So it's much more control in terms of the advanced cluster configuration. Now let's go through the various cluster configuration options, the various sections that's out there. And then in the next section, we will actually manually configure it. Okay, so there are several configuration sections in the console. You have cluster, tags, software, file system, hardware, security, bootstrap, and steps. Let's kind of understand what they are. In terms of cluster configuration, you give the cluster a name. That would be nice to give a descriptive name. So later on, when you have multiple clusters launched and they are in history, you can quickly get to the cluster that you care about. You can also set the termination protection on the cluster, which basically says that you don't want this cluster machine or the EC2 machine that is part of this cluster to be terminated by default. If you recall, in EC2, you can set a flag in the EC2 configuration to say that you don't want anybody to delete the cluster when you click on terminate. And that's what the termination protection is. You can also set the logging option, that you want the logging to be done and you want it to be captured into S3. You can also set debugging, which allows you to browse and search through the indexed log files. You can also configure sample applications that they have. In terms of tags, because your Hadoop cluster is a bunch of VMs and you can tag these VMs, you can go to the cluster and tag them. And when you tag them, they are propagated to the underlying EC2 instances. You can also configure your Hadoop software. Don't forget, you have the option to choose between the Hadoop distribution, which is the Amazon EMR Hadoop distribution, versus the MapR distribution. And you also have the option to select one of several applications, in fact, one or more of these applications. And then you also have the opportunity to do Hadoop software settings. For example, in Hadoop, there are many configurations. For example, there is the core site, HDFS site, MapRich site. These are all XML configuration files, and you can configure those settings too. In terms of file system configuration for S3, you can say you want encryption turned on. You can also define the consistency level for the S3 file system. In terms of hardware configuration, you can select the network VPC that you want. You can also select the subnet and the availability zone where you want these cluster machines to launch, which data center, that's what we mean by availability zone. You can also provide the node counts for the various instance groups. If you recall, I mentioned that there were 3 groups, that's the master, the core, and the task instance group. You can say how many machines you want. There is 1 master machine, which is by default, 2 core machines, and 0 task machines. If you want, you can change these numbers so that you can have 20 core machines and 10 task machines if you want. And you can also select the EC2 instance types for each group. Do you want it to be an M3 extra large? Do you want it to be an R3 machine? Whatever you want, you can choose in terms of the EC2 instance types. More on launching the cluster. There's also security configuration. You can select the EC2 key pair for the Amazon EC2 instances. If you say what the key pair is, they'll actually put the key pair in the EC2 instances that are launched for the cluster so that you can log into the machine and do whatever you want to do. So please don't forget to put your EC2 key pair. It's good to log into the machine. I'm going to show you that. Bootstrap configuration, you can select the bootstrap actions to run on all the nodes. We talked about bootstrap processing. There's also steps configuration. We walked through the various attributes that are there for step configuration. You can configure step units of work. You can do unlimited steps. It used to be that there was a limit to about 256, but now it's unlimited steps. And you can select whether you want to terminate the cluster once all the steps are done. And that would be the difference between the transient versus the long-running cluster. In summary, EMR is a managed Hadoop service from AWS. EMR has several features: easy to use, low cost, resizable clusters. You can use Amazon S3 or HDFS. They're nicely integrated with S3. You can launch parallel clusters. There is a bunch of Hadoop ecosystem application support like Hive, Pig, Mahout, and so on and so forth. There's also business intelligence tools support. For example, if you want to use Tableau with AWS EMR, you can do that. There's also management tools, AWS Console, API, command line tools. Security configurations can be done. There's MapR support if you care to use MapR distribution. There's also instance options. You can choose the various type of instances that you want depending upon what kind of cluster you want. You want a cluster that's high computation versus high memory versus high storage. And there's a lot of user control that you have in terms of steps and actions that you can execute. EMR integrates with several AWS services, including EC2, S3, Dynamo, RDS, and CloudWatch. In terms of the EMR architecture, you can choose between various distributions, the Amazon or the MapR distribution. You can have the cluster running in the transient state, which means it launches, does the work, and shuts down, or in the long-running state. There are different types of nodes. There is the master node, and there is the core and the task nodes. In terms of cluster states, there are different states through which the cluster goes. Starting, which takes a few minutes to launch all the VMs, then it bootstraps, then it goes into a running state, and then it goes into a waiting state. The running state is when the jobs are running, and then eventually it shuts down. It shuts down and then completed, which means it shut down and then completed successfully, or terminated when you actually terminate the cluster yourself. Or it may go into a failed state because something failed in the job. In terms of bootstrap actions, you can initialize nodes in the cluster by configuring the bootstrap actions. We also have the concept of steps, which are really a sequence of things that need to get done. The steps also go through various life cycles. It starts with pending, then runs, then it completes. If it failed, then goes into a failed state. Because it failed, the rest of the steps go into cancelled state. Several applications included from the ecosystem like Hive, Pig, Hue, Mahout, Spark, Presto, Oozie, and more things are being added on. In terms of the EMR working model, you can launch a cluster with steps that need to be performed, and then you can launch the cluster as a persistent cluster, which means it will be up and running until you terminate it, or you can launch it as a transient cluster, in which case once the job steps are done, it will shut down the cluster.